So let's start. Our subject today is mixed reality for social good. So if you look at the Wikipedia definition, it tells us that mixed reality is all about mixing the virtual and the real, right? Fairly intuitive. And the definition covers both what we call virtual reality and augmented reality. So the definition appealed to me for a lot of reasons. If you look at the VR or AR platform landscape nowadays, there's a lot of impressive technology out there. But I would personally argue it's still very early days, right? It's hard to tell if we're looking at a fad or if this is really the next big tech disruption. So that might actually be beside the point. If you think about it, in 2011, right, the big story is an 18-year-old, he builds a prototype VR headset in his garage, just a kid in his parents' garage. In 2012, he actually starts a company and launches a very successful Kickstarter campaign. And you probably heard this story before. 2 years later, Facebook buys this company for $2 billion. You know, very nice success story right there.
All right, guys. So
But this is not a story about some whiz kid alone in his garage working in a vacuum, right? This story would never have happened without a community. This story is really about community. And thanks to the smartphone revolution, what happened is that the right parts became available around 2010. Hobbyists like that kid took notice, and they then revived a very old idea, right? So for me, that's where the real magic comes in. Getting together with people from the community, making friends, learning new things, experimenting, right? The potential to create something new and to inspire others to reach new heights. That's the big deal right here. So on the idea of social good, how can VR or AR really bring about social good, right? Well, there's a few ways. We can look at direct applications of the technology. VR is an awesome learning tool. If you think about geography just right there, the VR edition of Google Earth is a really great example. So what could be a boring, mundane topic turns into this eye exploration of the world, like eye-opening exploration of the world. You can fly around like Superman and just find out, you know, how buildings are placed, what the actual place looks like. This is really crazy. If you've tried this, or if you have a Vive at the exhibition center, I really recommend, if you try one thing in VR, try this experience. Now, you can do a lot of more interesting things as well, like you want to create a time machine to explore historical events. So this is an installation that maybe some of you have seen that's hosted at the Palace of Culture and Science in Warsaw. You could also build any type of simulation. You want to navigate to the heart of the atom. You want to see math equations come to life. You want to stand inside a running engine. The possibilities are really, really endless. So there's also possibly more benefits to presenting material in such an immersive way. So here's a link to an article by Chris Nicholson. He's a researcher on Shopify's VR team, of which I'm not part of, so I don't represent them in any way. But in this article, he makes a really good point that humans are visual and spatial learners. So if you want to illustrate this, think back on your own high school years. I'm going to bet that it's difficult to remember the names of most of your classmates from back then. But chances are you could probably draw a roughly accurate floor plan of the school itself. By creating virtual spaces students can explore, you can really leverage that memory effect. In the field of journalism, we've seen very compelling use of the media. If you think about what life is like if you're fleeing from a war zone, or what the daily life for a volunteer is in far-off regions of the world, right? And finally, the field of healthcare. There's been a lot of research into how to use VR and AR for treatment. So there's a lot of promising research about relaxing, making patients that suffer from chronic pain relax. There's also exposure therapy to treat phobias. There's rehabilitation therapy. There's a lot of promising research in that field. So VR for Impact here is an umbrella organization that was created and is dedicated to make impactful, positive developments in VR, and also in other fields that are connected to that. But I have a question for you, right? Who stands to benefit the most from these advances in education and healthcare? I mean, quality VR experiences are very expensive to produce, and they're also expensive to consume, right? You need the headset. Those are expensive things. You need a super powerful computer. So we've talked about journalism also. On one hand, by walking in a person's shoe, right, you can sort of develop empathy, right? You can hope to make that empathy sort of more generalized in the greater public. But are Facebook and HTC or even Google trying to help refugees, really, with VR? Or are they just basically advertising a new high-tech toy that's pretty much built for the 1%? It's probably a bit of both. Ultimately, technology has great potential for social good, right? But potential is only going to be that, potential. At the core, it doesn't really even matter what type of technology we're going to be talking about. Does it even have to be about technology? Anyway, sustainable social good, I believe, is about community first. In my hometown of Montreal, I'm part of a volunteer organization that's called Osmos Academy. The idea is that passionate people come in, learn about these emerging technologies, and then try to apply it in the field as part of the volunteer effort. So since community is about building bonds with others, you're going to usually have a common interest, right? That will be the focus of your community. In this case, it's VR. But if you keep in mind, good communities also strive for diversity. So diversity of backgrounds and life experiences will make for a lot better learning experiences. You can see these ideas reflected in our charter I'm showing on the slide here. One of Osmos Academy's projects is called VR Passport. So the project brings together virtual reality experiences, brings virtual reality experiences to kids in hospitals. So it's a way for them to learn about the technology, for sure, visit new places. Even a small break from the hospital is often very appreciated. So in preparation for these hospital visits, what usually happens for us is that we have VR content creation workshops and courses that we hold. We've even had a kid-friendly workshop where participants could decorate Google Cardboard headsets that you can see here to be brought onto the hospital visits. So all of this really is to say that the interesting part about this effort is how it allows you to be very creative, and that might be specific to VR a little bit. You don't have to be a programmer to participate, right? Artists, designers, crafters, developers, there's a multitude of roles that can be played here. And in many cases, these roles are open to beginners and also still very interesting to experienced veterans. All right, let's talk a little bit about building stuff, right? We've talked about why, but let's talk about what does a project like this look like. As you might expect, it's going to be a mixture of various components, right? We're talking about mixed reality here, not only VR. And then, a mixture of components is a very good thing for the community building aspect of things. The wider the skill set needed to build a project, the more inclusive you're going to be able to be. So the demo project I'm going to show today includes 4 elements. So there's a real-world Lego model that reflects our virtual model. We're going to have a Android Things-enabled Raspberry Pi. So this thing enables our physical model to respond to virtual reality and augmented reality interactions. We're going to have a prototype AR terminal through which we're going to interact with the player in VR. And then we have a VR experience that's running off of Google's Daydream platform. Right. So first off, the Lego model. Why even have a physical model, right? The original inspiration for this came from this Audi mixed reality experiment right here. So the idea of this one is to scan a real-life model, and then we drop the players into it. The end result is, of course, pretty awesome. How cool is it to become a miniature race car driver? Who would not want to try this, right? That's fun. But while you're watching this clip, I want you to step back a bit and put your community organizer hat on. This is a really great project, like kids playing around in a sandbox, putting together a race car simulation rig, like a physical one with an actual wheel, 3D modeling, scanning stuff with a Kinect, programming a VR simulation. So there's a lot of skill sets required here, from anybody can do it to full-on experts. Another big source of inspiration for this project came from this game called Keep Talking and Nobody Explodes. So this one is a cooperative game. I'm hoping you don't hear the audio right here, but anyway. So the idea here is that one player is in a virtual room with a ticking time bomb that they must defuse. The other players are the experts who are going to give instructions to defuse the bomb. So what happens is that they need to decipher a very funny bomb diffusing manual to find out how to do this. The catch is they don't see the bomb, the VR player sees the bomb. So what's interesting with this is that communication between players is really key to win. And that takes care of the very big downside that VR headsets have, right? They isolate the viewers from the people around them. But by creating a mixed reality experience like the ones we're talking about, it's possible to do the actual opposite, right? You can create a shared experience. So if we go back to our project, the idea is to build an interactive model and link it to a VR simulation and that AR magic window. Right, so you might be thinking at this point, 3 platforms, right? How are we going to get them to talk to each other? So for the quick MVP, we'll be using Firebase database, real-time database. So this is not a Firebase talk, so I'm not going to go into the details of hooking everything up with Firebase. There's a lot of great material out there. If you have questions about that, I can point you to that after the talk. But if you're not, say, familiar with Firebase real-time DB, so the general idea is that the model that you have saved in Firebase is subscribed to by all the other components that are around it. So whenever one of the components, be it the Android Things platform or the player in the VR, writes to the model, all the other components will be pinged on that and will be able to react to that change. Okay. First part, we're going to talk a little bit about electronics, the Android Things component of this sample project. So Android Things supports the Raspberry Pi 3. And this is what I used here, right? It's very accessible, it's fairly cheap, so that's a pretty good baseline for a community project. Excuse me. So in this little story, our player is going to be exploring the multiverse. Let's say we have 2 roles. We're going to have explorers and scientists. We're going to start in a lab that you can see here, from where the scientists will assist the dimensional explorers, right? So in this lab, we're going to want to have an interdimensional portal. And we also have a conveyor belt here that the scientist could use to transport objects and people between dimensions. All right, so let's start with something very simple, and we're going to add a blinking LED to our model. So to be able to blink the LED when our explorers want to send things back through the portal, or, there's other ideas that you can come up with, but the idea is to give physical feedback. That's a nice touch, right? The electronics for this type of thing is pretty simple. The way it works is that you have what's called a GPIO channel. Like in this case, it's GPIO 12. It's a pin on the actual Raspberry Pi that's going to be hooked up to the LED. And that's how we're going to control the state of the LED and turn it off and on. On the software side, things are not too complicated. So when we're starting an activity, the way Android Things work is that you get a GPIO instance from what's called a peripheral service manager. Now, I'm taking the assumption that maybe half of you in the crowd are Android developers. For other people who are not familiar with Android, the key takeaway here is that most of what you see on the slide is the code you need to make that light blink. So even if you're not super familiar with Android, from having done it in community workshops, people are able to grasp this stuff and play around with it. It's fairly accessible. Right, so in our case, we grab an instance of the GPIO 12 in the first part of the code. And then in the onResume block, what we do is we set up a loop where every second, we're going to turn that LED on and off. All right, so to make things a bit more interesting than just having one blinking light, you can add mechanical interactions to your projects. So in this case, we're demoing using a small DC motor to make the conveyor belt move back and forth. Here, things get a bit more complicated on the electronic side of things. The reason this is kind of a semi-complex diagram is that you need to isolate the power supply for the DC motor from the logic circuit, in this case the Raspberry Pi, right? The power requirements for a DC motor are very different than for those of a Raspberry Pi. By using this component, this being the L293D chip, I'm pointing at the screen, of course you can't see that. By using that chip, we can make sure that turning off and on the motor won't mess up the Raspberry Pi. It isolates both the power circuit, the battery pack in this case, from the actual Raspberry Pi that has its own power supply. So if you want to build your own version of these things, the best site I can point you to is adafruit.com. They have really great tutorials for simple projects like these. There's one very similar to this one that I took as an inspiration to power up a DC motor. Okay, So on the coding side, again, I want to show that it's relatively simple code, right? There's not a ton of it. There might be a lot of new concept if you haven't done electronics, but things are still understandable. In this case, what PWM stands for is pulse width modulation. So that's how you control the speed of a motor, right? There's a pulse width modulation is also something used in a lot of other electronics projects. So that's one of your baseline sort of key building blocks. You might notice that we have two pins, GPIO 20 and 21. So in the diagram before, you might have seen that. The idea is that those two pins are used to control which direction the engine is going to go, the motor is going to go. So by flipping the bits here, instead of having true and false, by flipping those values to turn them into false for 20 and true for 21, we'd make the conveyor belt go in the reverse direction. And the last line is just really, you enable that PWM generator, and that's when the motor will turn on and make the conveyor belt move forward or backwards. Right. So if you're very new to electronics, the Android Things website has you covered with the Hardware 101 section. You can pretty quickly experiment with these things, even if you have probably no previous experience. Of course, that's a bit subjective since I have a little bit of previous experience, but from what I've seen, most people are like able to tinker with electronics without necessarily having done like an electronics course in college or university. So anyway, I recommend you check out the hardware site for Android things and also Adafruit. With that, I think most people can get started and start tinkering around. The other interesting idea is to get a Raspberry Pi starter electronics type kit. I got mine from a local electronics hobby store. It's kind of an old one. It's for V2 instead of V3 of Raspberry Pi. But a good Raspberry Pi kit will have a detailed manual. It doesn't really matter which version you have. It's going to teach you varied projects to start with the basics, and you'll get a lot of mileage out of this. And you can probably teach a community even with just a simple kit like this one. All right, let's move on to the AR Magic window. So at this stage, our Lego lab has the basic components for real-world interactions. So how do we augment this setup? We're going to add a basic portal effect in the doorway. And also to complete the effect, we're going to add a virtual object on the conveyor belt here. So originally, I wanted to use Project Tango to do this example. Tango is a technology stack that's been created by Google. So what happens is that they have specialty Tango branded devices with extra sensors and cameras. And these sensors and cameras allow a device to keep track of where it is in 3D space, where it's facing in 3D space, and also it allows it to see what's in front of it and sense the depth of things. While Tango is great, the problem is that it's not exactly what you'd call accessible hardware or technology for most people. It's kind of complicated to code for. The hardware is fairly expensive. Like you're going to need to spend at least $500 to get a device. So instead of doing this, I ended up going with Jérôme Etienne's 3JS Web AR extension. He's had, well, I should say his team has had great success building AR scenes at 60 frames per second renderings on even 2-year-old Android phones. So that library is web and JavaScript based. It makes the technology super accessible, again, to a wide range of people, right? Perfect for the community projects. Little side note there before we move on. If you're curious about Project Tango nonetheless, I've done a talk on this subject at DroidCon New York last year. So this talk's going to show you how to get started in building an AR magic window using Tango. Please feel free to ask me after the presentation if you want more information. The link is below. You can watch that, and it has a GitHub associated with it, so all the code is there if you want to experiment with that. Okay, so the first thing we're going to need to get ARJS working is a visual marker like the one I'm showing right here. The library uses image recognition to find the pattern in a video feed. Then it anchors a 3D scene based on the position of the marker. So then what we need to do is to map our virtual model onto the physical one. The calibration phase involves placing the marker on the model itself. The key here is that the size of the marker is what determines our scale. So that means that our marker here being 1 unit by 1 unit in the virtual world, and it's laying flat on the X and Z plane. So right now, what we have in the code is a 1 by 1 by 1 cube that we can see transparently sitting on top of the marker. And to make things sit on top of the marker, it had to be moved half a unit up, because most 3D things are centered around the 0, 0, 0 origin, right? And the 0, 0, 0 origin in this case is the middle of the hiro marker on the model itself. Anyway, that's a small detail. Ignoring the configuration boilerplate that you would typically find in an ARJS example, this here is the code that you're going to need to add the transparent cube that we see on the marker right here. I've also added something called an access helper object to the scene. So this is what shows us these X, Y, and Z axes in red, green, and blue right here. If you're new to 3D, the main thing to remember with this is that creating a 3D scene is in 3JS, which is under the ar.js library, is actually fairly simple. The library is well documented, and people tend to pick it up pretty quickly in our own community workshops. So it's a pretty good library to play around with. All right, so we're going to want to map our virtual objects onto the video feed, right? Those virtual objects are going to be Legos. So we're going to need the real-world Lego measurements that we can see here. And we're going to add these measurements to our simulation. So by making the relationship between the size of the marker and what we want in real life, from real life rather, the size of the marker as it is 1 by 1 by 1, and in the real world that would be 32 millimeters per unit. So knowing this, we can create all these measurements for Legos that we can reuse in our little equations later on. So based on that, here's a function that will be able to create objects in Lego units and place them into the real world model. So that allows us to create blocks of the right dimension fairly easily. So here's code that will add two of the things we wanted. So the object on the conveyor belt and the portal in the doorway itself. You might notice that the alignment is fairly off in this example. So one of the few challenges with these kind of projects is that you're going to tinker and find things on the way, and sometimes things don't go exactly as you plan and you lack time and all that. But that's part of the fun, right? But here, and specifically in this case, what's probably happening is my hero marker is probably a little bit too small for the library to recognize it properly. And I've had sort of varying results between different phones and different PCs. So that's stuff to keep in mind when you're going to start experimenting on your own projects. But the point really being that adding these objects in the AR space is not that difficult. If you look at the code again, you just specify the size of things, you specify the colors, what type of material you want, and they'll appear in your window. All right. So third part, VR, Daydream, and Unity. So this is a little bit more involved. Let's go right into it. We're doing good on time. All right. So the lab prototype is done, right? What happens on the other side of the portal? At this point, I was really out of ideas. I didn't know what to do anymore, so I reached out for help. So this is Nina, my creative director. In our case, now we're in our dimension. Once we step through the other dimension, we're going to have Mr. Halloween guy at the bottom left here that wants to go say hi to his friend Birdie Buddy all the way in the top right corner. So to say hi to Birdie Buddy, we're going to need to open 4 doors. These are the white Lego sticks we see on the way. The person wearing the headset will be playing the role of Mr. Halloween guy. The person outside the simulation, the scientist in the lab, will be trying to help Mr. Halloween guy when he faces obstacles on the way. So the Daydream simulation is where a lot of the narrative is happening, really, so let's explore it now. I've decided to use the Unity engine to build these VR experiences. So the reason for this is that with Unity, we've had a lot of great success. I'm actually not a end-all fan of Unity. It is a really great platform. A lot of great games have been built on it. Typically, I like to be able to interact more with like the Android platform side of things. But in the community efforts, Unity really can't be beat. It opens up the door to developers of all levels, and I keep going back to this because obviously that's very important, right? You want everybody to be able to participate. And the Google Vr Sdk for Unity is pretty good. So when you want to install it, you're going to want to follow the instructions on this page. The link is at the bottom. It's going to get you most of the way there when setting up your environment. One thing to note at this point is that the latest version of the GVR Unity SDK is best used with a fresh install of Unity 5.6 beta. Before I go forward, the other thing to note is I suspect that next week, since it's Google I/O, so that's Google's big developer conference, I think we're going to see a big upgrade to this. So by the next week, or by the time you start experimenting with this, these notes might be obsolete, and of not of the problems that you can see here will probably be fixed, right? So this is really more for the day-to-day Android developers. These issues you do need to be aware of. Under the hood, Unity's latest version is still expecting an old version of the SDK tool, the Android SDK tool, to prepare a build. So you're going to want to have a separate Android SDK installed for Unity if your day-to-day is actually developing mobile apps. You can grab the appropriate zip for your platform, configure Unity to use that install instead. There's also an issue in there with the Daydream controller emulator. For now, you're going to want to edit the emulator client socket.cs files. Anyway, you know what? Too long. Just take a snapshot. You'll probably be good after that. Right. So the next thing I recommend to do, this is a personal thing, I would recommend you install JetBrains' C# IDE called Writer. I personally have been staying away from Unity for a long while because it uses something called monodevelop, which I find a bit hard to use when I'm used to different tools on the day-to-day. Writer has a very nice Unity plugin, so you get all the powerful features you're going to be used to from an IDE like Android Studio or IntelliJ, and that could save you time and maybe make you more efficient. Right. And next, if it's your first time trying Unity, spend a bit of time with this Rollerball tutorial. It's going to teach you the basics of world editing. You're going to see how to add 3D objects to a scene. It's going to teach you the basics of camera lighting, materials. You're going to learn how to add scripts to a game object and how to apply physics. It's an hour really well spent before diving into the Google Vr Sdk itself. That said, don't worry too much. Using the Google Vr Sdk is very straightforward once you're familiar with Unity. The first thing you're going to do, shown here, is to add the provided GVR Viewer main prefab to this Unity scene. Prefabs are things that you take, Lego blocks basically, that you drop into your Unity scenes to get going pretty quickly. When you're going to preview now this scene in Unity, once you've added this viewer, you're going to have full stereoscopic 3D right off the bat. And you can also note that the preview simulates the distortion connection that you're going to get on the phones themselves. And you can emulate the user's movement using your mouse by clicking around. So that's a very nice environment to sort of prototype. Next, to use the Daydream controller, you're going to add something called the GVR controller main prefab to your scene. Under the UI prefabs folder, you're going to also find something called the GVR controller pointer. Adding this to your player object, it's going to add the actual controller model to the scene so that the player in VR is going to see that controller when they move their hand. Right? You can see that here. And so next, let's install and bring up the Control Emulator app on a real device. So I've just launched this. This allows you to take your phone that's connected to your laptop through USB and emulate a Daydream controller. You can also pair it up to a real Daydream controller with this. So once this is paired to the connected phone, you can see that we can use the controller and move our hand about. So this is me taking my phone and just pointing at the sky. So this is very, very useful when you're going to be developing, right? Because otherwise it's very hard to sort of, whenever you build an app with Unity, it's going to take a few minutes before it ships on the phone. So if you want to prototype rapidly, you're going to need this. All right, let's go back a little second to Mr. Halloween Guy and Birdie Buddy. We haven't put doors in yet our scene, so I'm going to have to ask you to use your imagination a bit. How are we going to get from the starting position to Birdie Buddy over there? The baseline locomotion mechanics in VR, it's always some form of teleportation. The reason for this is typically that if you make movements from point A to point B, you tend to induce nausea in most players. But if you teleport instantly to where you're going, that alleviates that sort of problem. So there's just to say that the link below the slide is a detailed tutorial on how to implement all of this in Unity. We're going to go quickly over the basics regardless. So let's see. All right. The general idea with Unity is that you assign a script to the object that you want to react to something. In this case, we want it to react to being clicked on with the laser pointer, right? So this is the controller dispatcher, and we have associated with pad 3 right here. And then, using something called an event trigger component, that's how you register to the interesting events, right? So we can see that there's events such as pointer enter, pointer exit, pointer click. So here, enter and exit are going to control the color changes that we see when the pointer floats over one of the teleport pads, like this. And we can see that when we click on this, well, you can't see me click, but when I clicked on this, we teleported instantly to the teleport pad. And that's the code that was sitting with pointer click. Right. So now that we have basic locomotion in place, we're going to add locked doors to the scene. To make things more interesting, we're going to have color locks on these doors that are flashing here. The color locks are basically the color block, right? We're going to have to pick a color, and when we've picked the key of the right color, by clicking on these blocks, we're going to open them. If you had more time, obviously you'd build like a proper key of a specific color, put an actual lock. Like these are developer design skills at work. So all these nice little blocks, right? So in our actual simulation, these keys would not be available right away, right? The VR player would call out to the scientist in the lab, "Hey, I need a red key right now. Can you send it through the portal?" Just to explain. So it's the job of the player outside the simulation to give them the right colored blocks flashing here and to advance through the level. And if we only focus on the VR side next, the player's going to need a way to pick up that key, right, and use it on the door. And when the door is unlocked, you're going to want that door to open. So let's see how we're going to do that. So first, we need a way to pick up objects. Simple enough, right? We're going to point to an object, click. We already know basically how to click on things and click on things and store references to them in some sort of inventory, right? That's great, but we also are going to need a way to communicate to the user exactly what they're holding. So we're going to add a key holder sphere to the scene, right next to our controller, right there. That's gonna, and then we're going to make it change color depending on what the user clicks on. So that's going to be basically our inventory indicator. By changing color, we're going to see what exactly we're holding right now. So we're going to want a pick key method to be added to the behavior script of our key objects. So that's the key object right here. We go into the inspector, and then we basically want to make sure that the following method is part of the code. So this pick key method is going to be reacting to picks and clicks, and it's going to assign the key color to the inventory of the player. So to finish, we want to make sure that all the script instances for all the keys point to the right holder. Once this is done, right, the key holder being, again, the sphere next to the remote itself. So when we have all this set up and we're going to click on the key, we're going to see the key holder change color to indicate to us what we are currently holding. So it's kind of small at the beginning of the video, but you'll see we're pointing at the different cubes. We click. Hopefully that's visible for you guys over there. But so we click and when the color changes. A little bit later, I have the remote coming up right there, so we can see a little bit what we've picked. We have a red one. We have the green one. So you get the general idea, right? We now have a way of knowing which thing we're holding. And if you have a bit more time to make it look nice, you can add specific graphics to float next to the remote, things like that. All right. So next, we're going to want to be able to open the doors. So we're going to quickly go over what the basics of animation are in Unity. It's got a very nice animation system that's kind of perfect for this type of thing. It's fairly easy to use. So first thing you're going to want to do is create a new animation. In our case, it's going to be called door opening. So we're going to do this now. Right, so I'll open it up. So we have the door opening animation right here, which is going to be associated with the door. And then you have an animation panel that we're going to look at now. So while going in there with our door selected, we can start assigning properties that we're going to be wanting to animate. In this case, it's fairly simple. We want to animate the height position of the door. So we select that position, and we put the marker where we want it to be in the animation to set the values, right? We want to set the value at the beginning of the animation. We want that door to be down there. At the end of the animation, we're going to want to be open all the way up. So next, we're going to want some sort of trigger that's going to start the animation when an unlock event happens, when the user clicks on the colored block with the right color key in hand. So Unity's animators allow us to build complex state machines to control animations. This is about the simplest you can get, but you can control things like characters running around, all of this. Our door state will be a very simple affair. It's going to have an idle state on start. It then moves on to an open state. The next state after that is going to be close, fairly obviously. And then when the close animation has happened, we're going to go back to idle mode, where we're going to wait for interactions for the user. To reverse the animation when closing a door, you simply set the speed to -1. And this is going to be the final result right here. We can see I'm toggling the door's state from open to close, and then door's opening, door closes, we go back to idle, we click again. That's the general idea. It's fairly simple to set up these basic animations, and most newbies can get around to getting this to work maybe with an hour of exploring Unity. Okay. So that's about it. There's a lot of takeaways here, and I just want to go over them very quickly. You can teach a lot of things to volunteers, and even if they're not familiar with the technology, a lot of the building blocks I showed you today, somebody new to this can come in, start playing around with it, and have a lot of fun. We've had even people with zero programming experience start mucking about with Unity, and they manage to make things that would blow you away. Everyone can help, so kids or adults can help with model making, electronics wiring, all sorts of interesting stuff right there. If you have adults that don't know how to code and they don't feel like coding, maybe they don't like this, they can make assets, they can make music, they can make 3D models, they can make drawings. We have stuff for all levels of development experience. So there's Unity is a nice option. Java native, if you have people that can do this, definitely try to add that to your projects. JavaScript, C#, whatever, it doesn't really matter, right? Like the tools are here, and we have a nice palette right here, but there's a lot of other things out there that are simple to use that you could consider for a similar project. Being a mixed reality project, you can introduce a lot of different things, and it still can make sense. It's a very rich environment for growth for everybody that's involved, so that's very important. In our case in Montreal, we know that the kids in the hospitals love this stuff, and it's been really a wonderful experience. So bottom line, building a social and experimental platform is going to make both the process and the result worthwhile and very impactful. Thank you very much.
Thank you, Etienne. So, short QA session. Do we have any questions for Etienne? Not much, so maybe I will start. So could you name or like a couple of interesting projects that you have realized with your academy or community that you, because I understand this, the whole point is about the process, but I guess that you probably have realized some fun projects, right, internally.
Yeah, we have, so we have one that's sort of gone out to the hospital. Like we have a couple more internally that we're rolling around. So our organization has been around for like a year. The first experience we have is a VR experience that was built for Google Cardboard. It was built on Unity. I actually sort of debated if I should include the video, and I wasn't sure we'd have time. But the idea is that we've built this experience where the kids are roaming around in a seafloor sort of environment. We have corals, fishes, and school of fish floating around. And the basic idea was that a lot of the kids in the hospitals have limited movement, right? They can't even really use a Daydream remote in some cases, So you have to think of an experience that will support both the kids that can only look at stuff and the kids that want to be a bit more immersed. So in our case, we would have the school of fish follow the user's gaze after a while if it was staying in one space. If you had access to remote, though, we would allow a lot of interactions to happen. So that was our first basic project, and right now we're mostly in another development phase where we're playing around with the mixed reality stuff I've shown you today, and we have a few other things that are kind of interesting. The team went to a hackathon, was it mid-April? So I didn't participate in this one, but I saw the result, very interesting stuff. So they had the game was basically the VR player was in a small room and starts to hallucinate. And the doctor is trying to determine what kind of psychological symptoms they're showing to prescribe the right medication. So the whole loop is your player is sort of hallucinating, they're describing what they're seeing, the doctor administers drugs, and the effects change or get better depending on what's just happened. So that was a fairly interesting experiment. And that was done with the Vive, so you can imagine walking around and your senses are cheating you. That was kind of fun.
Okay, thanks.
Pleasure.
Does anyone has any question? All right, no questions. So thank you, Etienne, for joining us from Canada and for this detailed walkthrough, building our own mixed reality experience. Thanks a lot.
Thank you very much. It was really a pleasure.